Hi friends, welcome to part 2 of video 6, where we continue exploring the Chazy Reef reef structures on Isle of Motte, Vermont, and just wanted to warn you that there will be a part 3 to this series, because I can't stop with this sort of cocaine-esque experience of learning about geology. And cocaine-esque is perhaps a melodramatic statement, and yet one that I'm tempted to make, because it really boggles the mind. It boggles the mind. And so part 3, this video, we're going to look at fossils. And I'm just going to kind of show the fossils and kind of speculate. I don't know shit about this at all. So I might mix up things like corals and sponges a few times, maybe. And one thing you'll notice in this video, and you might have noticed in the last video, is that there are these interesting fissures in the limestone that we're looking at, and they're kind of parallel to each other, but they're kind of irregular. And basically, that's easily explained. It's tectonic stress has just created what's called jointing, just breaks in the rock, not movement, not faulting, but just jointing as these parts of the Earth's crust were subject to the tectonic stresses that produced the major faults that you can see in the cross-section of Isle of Motte that we looked at in the last video. But basically, these joints are, these breaks in the rock are parallel because that tectonic stress is very uniform, when it's going on. And, maybe there's a torquing, maybe there's a pressure, maybe there's a stretching. I don't quite know. But anyway, it does that. And then limestone simply dissolves slowly in rainwater, because rainwater is a mild acid, because there's always some amount of CO2 in the atmosphere. More and more now, of course, but, always. And since the rain falls through that, and it becomes a mild acid, and carbonate is very reactive and dissolves in acid, and it forms those interesting fissures. So that's what that is. I'll also, and I guess I just want to highlight one limitation of the video. And when I'm talking about limestones and stuff, I'm talking as if these rocks are primarily formed through chemical precipitation in warm tropical seawater. I mentioned that, I mentioned that phenomenon, and that is a phenomenon that does happen, and that is one way carbonates form. Flakes of calcium carbonate simply appear in seawater at certain temperatures, certain salinities. And, I don't really know anything about chemistry, but that is something that happens. But actually, the primary way that this lime mud, I talk about lime mud, and that's, the sedimentary precursor to limestone. The primary way, actually, that lime mud is formed is not through chemical precipitation. It's through biogenic precipitation. I think that's what they might call it, biogenesis, or it's really is fully mediated by life. So you have different microbes that produce a calcareous part, a calcified skeleton of some kind, and when they die, they form grains of sediment, right? So there's that, and there's the myriad other things that produce those structures. And they're classified according to the size of the grains of sediment they form. And geologic time is so immense that there's so much that they can build up so fast. Just these biogenic sediments can build up faster than sea level rise, et cetera, et cetera. So it's an amazing phenomenon, and going to get to that more in part 3. But we're going to finally look at fossils here. And I just want to mention one other thing. There's some images of stromatoporoid fossils coming up, and I talk about them as looking like nipples of slime, or slime nipples. And this is hilarious to me because I was just kidding around. The inherently somewhat grotesque nature of geology and just materiality, but that's okay, we love it, inspires similar responses in similar people. So actually these are technically called mamelons or something, MAMELON, i.e. nipples, right? Latin word for nipple. So I guess this is what stromatoporoids do. This is the outer surface of this sponge, this calcareous organism. So I was proud of myself with that, and with that, we'll look at some fossils. And if you want to continue the deep dive, part 3 will be another long video about in more detail about just what carbonate rocks are, and just how amazing and mind-blowing they are, and reefs, and the whole vast geologic history of reefs, which I'm just gonna luxuriate in, and hope you enjoy it. But the main thing is that I enjoy it. All right. So like I say, I don't know what I'm talking about, but I'm just going to go out on a limb and really strongly hypothesize that this is reefoid. It looks alive. It looks very much alive, not in the normal way in which all bedrock is alive, but it looks like life. It looks like it's vibrating with life. It looks like life made it, in various ways. But, look at these strange sectors of, something there's an undulating surface that's been sliced. There's something, this could be, see that wavy line running through, sliced off, stromatoporoid. But also in the mix here is this interesting little guy. I don't know what that is, but that's something. It's got a nice crisp shape. It's not eroding as much. And thought I'd just stick that in here. This is zoom out here. This is a nice little section of that reef. More. Here we have a nice little zone amongst the Juniperus virginiana here, generally contributing. But so first thing here is you can see the beautiful spiral, and they're calling that a gastropod on the interpretive side. So some sort of big snail, a grazer, grazing along on the mats of the slime that's available. But this is another one of these, I just don't know enough to really know what I'm looking at. It has ribbing going that way. It's oval in shape. It sort of reminds me of a couple ones I've seen so far. I don't know what this... All right. Not sure what made it into that last video since my battery cut out, but We're at Discovery Station 4, so-called. And I just wanted to zoom in on some particularly dramatic fossils here. They're calling these cephalopods. So, kind of a long ice cream cone with this ribbing. And out of the big end of the ice cream cone is coming a whole profusion of tentacles and eyes, 2 eyes, thank God, and mouth, you know, so forth. But yeah, this shell here, someone's been messing with it. There's some blue residue on it. People love to mess with stuff. Present company included, I suppose. Yeah, this is a jumbling of the fossil, I guess. And I don't know. This tail goes this way. It could be, and this. I'm wondering if this. See how it's spiralized in this beautiful way. But is that the ice cream cone, sort of in cross section? I guess that would be my question. And is that spiralization corresponding to the ribbing that we're seeing here on the side? These are some good questions. Anyway, cephalopods in the Chazy formation. Chazy. And it's a beautiful thing. Il y en a masse. Il y en a masse. Il y en a de plus. Gastropod. Beautiful. So I guess inside here is a big snail body, and the foot comes out and it slimes along and grazes. But there's a lot of them on their sides. I wouldn't know how to recognize them not on their side. The mowers have been here, that scourge of humankind and many other things besides humankind. But yeah, I think maybe our last little segment in this fossil series will be the beautiful gastropods that are visible on the Motte Historical Society walls. There's another one. There's a lot in here, you know, and just looking at this irregular surface. Drinking cold Motte this morning. It's good. But yeah, so look at the different quality of the rock here. Like, I think what I'm standing on here is this mud, lime mud, just precipitated out of the seawater, calcium carbonate, at a high enough temperature under the right conditions. But then as we look what's overlying this mud, what we find is this lighter colored stuff, material, and it's lousy with gastropods and just undulations and irregularities. And it's a reef. It's a fucking reef. That's what they're saying. And I don't see any reason to doubt that assessment, personally. Alright, but so what the hell is this? What is this? What is this thing? It's got some parallel ribbing there, oval in shape. I just took a tiny stick and scraped out the sand that was in there, but it almost looks like like a geode or something. It's crystallized inside, or maybe dissolved and then seepage has recrystallized. But what is that? Sponge? So I've seen a couple like that. I just, inquiring minds want to know. All right, so here at Great Falls Geology, we work with what's at hand, and this would be the site we were just at a little while ago, and I'm just looking at these beautiful cephalopod reconstructions. Hopefully they have a nice colorized version of that ribbing. I assume there's a spiral inside there growing that way, and that's what's making the ribbing, but they've colorized it, I guess. Nice little octopoid creatures. Oh, they're great little eyes, very cute. And is this a kind of helmet, a retractable helmet perhaps? And is this area of the fossil the jumbled remains of that little head covering? Maybe. One can always wonder. Alright, so this is some impressive stuff. Just look at all the gastropods around here. Basically, snails. There's another one. Zoom out. If you just sit here, how many can you see? There. It's easier to see them in. One there. Let's see here. Right there. Got some humans coming. Just this whole outcrop. So we got some, oh yeah, down here. Look at that. It's just how much of this is actually gastropod material, you know. And of course, erosion has nicely revealed the darker shelly part, and I guess the other stuff is whatever filled it. But basically, this is some nice topography. These gastropods are just piling up. You know, they're piling up, and see the bedding there. But that rounded, irregular topography, I think it maybe is the reef is a little more erosion resistant than the mud, because it's instinct with life. Those telltale squiggles. It's just everywhere. And maybe sometimes they seem to be on their side a lot, you know, which would make sense. Dead, flattened on their side. Alright, what else can we find here? Okay, here's a poking out here. I guess that's a cephalopod. Gastropod. Oh yeah, look, we can see it's ribbing. Rhythmic ribbing in a central thing, but then okay, but this is interesting, because here we have a gastropod. This is the cephalopod. This is a gastropod. Later in evolutionary history, cephalopods spiralized, and they started looking a lot like these shells, but not yet. So there's another one peeking out there, that cephalopod. But here's a gastropod in 3 dimensions, I guess. And, you know, most of the time we're seeing them, and they're sliced. This tan sediment, I think, is a sandier sediment that's come in and filled the inside of that shell. Anyway, so we're seeing them sliced, but here's one maybe in 3 dimensions. It looks like it's been molested by humankind. Scratched there, battered there, maybe revealed a little bit. That could be a little echinoderm section, but that's interesting. 3-dimensionality. And God, there's just so much around here. Topography, an ancient shallow marine reef, beautiful gastropod. That would appear to be a kind of Maybe the outlet of the horn or whatever, the spiral. Oh, I thought there was some sponges. God, they're beautiful. The way it's been eroded is very suspicious of, I think maybe the upper surface of this reef has been exhumed. I'm just going to throw that out there as a hypothesis. Has the upper surface of this reef been gloriously exhumed? Like glaciation and various factors of erosion. Okay, here's something interesting. So this is much larger and clearly concentric rings with, well, little barriers in the ring. I don't know. So is that slime? Is that this reef-forming stromatoporoid that I know nothing about that they keep mentioning? Who can say? Who can say? I don't know what this is, but it's pretty cool. Little, let me see here. Oh, maybe that's a fool's errand. Radiating out from kind of central point are these parallel lines, and they end, it's not a lichen, it almost looks like a lichen, but it's definitely part of the rock. Zoom in, is that a coral? Is that a coral? That's my question. Yeah, just a beautiful gastropod-rich zone here. Customary human molestation included, I suppose. But here's the cephalopod. There's that cool ice cream cone, which I am just lapping up, and strange and wonderful gastropods, some of them accentuated by lichen, which is fun. And I'm just noticing in here, you know, what would that be? A spongy? Little spongy spongerkins. But we pull up, and then it's more muddy on top. So maybe we have some reef layers, mud layers. Back to reef layers, I suppose. Oh, I'm running out of batteries here, but there was some cool stuff around here. Humans. So distinctive. There's some interesting gastropodic swirls, but eroded in a different way on the nose there. And then this is quite interesting. What is that? It's some struts. And just all this shelly material jumbled up. Oh, and I'm pretty sure that's a sponge. Yeah, I think that's a sponge, because you see the radial quality radiating outward, and it's got a nice three-dimensional peak to it. But yeah, so that would be the sponge, but not the principal reef builder, I guess. Look at some of these rocks from the side. You can see some interesting, curious things. I thought down here, well, back to where we started, aren't we? Yeah, what does that? What makes the undulations like that? Why a road like that? Just random. Interesting. I don't know if those are econoderms. I think those are little nipples of slime. Maybe. Slime nipples. This is nice. These nice wavy lines here. And very topographically elaborate part of the outcrops here. So the interpretive people are really going all in, calling these stromatolites. Basically, also known as you can call them microbial mats, biofilms, or my personal favorite, slime. And slime it's photosynthetic slime, cyanobacterial slime. I think it's pretty similar to some stuff that you still find quite a lot of. Anyway, it grows on top of itself because successive sedimentation events, depositional events, choke it out with sand and silt infused into the system, and then, but it doesn't completely choke it out. It recolonizes on top, and it makes these beautiful domal structures. But here I think the domes have been sliced through by erosion, and we see these wavy lines. Nice. This is nice. This is almost a good one to start with, because in the foreground here, blander, grayer, more massive, less stirred up, less variety in it. I think just a kind of a lime mud. I mean, I'm thinking, you get in close, it's just maybe you can see some little fossils in there. It's hard to say. I mean, but anyway, you get up here, things change. Undulations, swirls, cyanobacteria. What else can we see here? I guess this is the swirling, and beautifully exposed. Alright, so this is some cool shit, man. Let's try to figure this out a little bit. You're gonna focus. Yeah. Alright, so we look close here. You can see a kind of a network. Yeah, there's a good glimpse of it. Had to get my optical machinery to obey. There. So I'm wondering if this is, look at that, a cross section maybe through the stromatoporoid body. This is a relatively recently exposed chunk here on the reef. So I'm learning from the interpretive signs, and I just want to do some observation here. So see these nice bubbles, nipple slime, I think I called it before. There's some, but I'm thinking that's what they're calling stromatoporoids, which is kind of no relation to stromatolite, which is interesting. Maybe stroma. Who the fuck knows what these words mean, but they need to be learned. They need to be learned. But this is what the interpretive signs are presenting to us as a section of the patch reef. So it's not a continuous reef. It's patches of reef. And you see where the jug is sitting and where my motte is over there. And right there, that's a contact, they're saying. A sedimentary contact between the reef, the material formed by these stromatoporoid reef builders, early sponges, and they're pretty much coming out and suggesting that this is not stromatolite slime, this is stromatoporoid reef building, I guess, and it has these funny little circular blisters, erosion. There's a nice one. There's a nice zone of them. I'm just noticing they seem distinctive. Oh, one of those kind of circular structures. Who knows what that is? But and then in this zone where the jug is sitting, theirs has a tannish color to it. Everything is eroded, but I think what we're seeing there, they're calling that the mud layer. It does have gastropods in it, embedded in it. There's one. There's another. That's a very beautiful one. But it has this tannish marbling, which I guess is maybe something to do with the way the lime mud is deposited, and then a grayer color, this patch of reef on top of it. And is this another patch of reef here, slightly lower than the other one, but maybe just a little fragment, a little reef fragment? And are those stromatolites or stromatoporoids? So many questions, so little time. Hey, well, this is a very beautiful, nice chunk of rock, but questions, so many questions. The interpretive sign at the last site is really declaring this is a stromatoporoid. Okay, well, how do you tell it from a stromatolite, people? Help someone out. Help out an amateur geologist. This is not the most crazy question in the world. Are those sponges, those concentric things, those blobs sitting there with a radial? And so, yeah, they're saying stromatoporize. They're saying you can sort of see year-on-year growth. And, maybe you can. Maybe you can. How would I know? But to the somewhat initiated, but recently initiated observer, looks like a fucking stromatolite, man. So help me out. Help me out. There's some interesting stuff going on in there. Couldn't they have polished this instead of just slicing it? Couldn't they have polished it? Is that too much to ask? Little shelly material piling up there. Think that's fun. That's fun. Maybe spongy material piling up there, coarser, finer. Are we seeing some deposition? Maybe. I'm gonna come over here. You can see the three-dimensionality of the whole thing. And I don't see any echinoderms exactly that I could really put my head on a chopping block and declare, but it's a pretty nice block. Well, sea lilies are not. A lot of them, they're all different sizes. They have this central canal. I think maybe no, bryozoans. I haven't really been zeroing in on what they're calling bryozoans, and it should be a tubular organism that forms branches. Although I'm looking here and that sure looks like maybe a sea lily cylinder. I don't know. Some good stuff. Real good stuff. Here's interesting area. And into the sunlight. See the wavy pattern there. Maybe that spongy thing. Oh, I just can't stop. Some cool shit, man. Alright, you see this? See how it has those little light colored flecks on it? Well, interestingly, getting close enough, they just kind of disappear. It's fun. It's kind of fun. But I'm really thinking sponginess, and I love this one. It's been cut across, I guess. Are these the little relics of the inner structure of the spongy sponge? It's interesting. Succulent plant with these dried flowers or seed pods from last year. I'm gonna take some pictures of that too. That's interesting. What the hell is that? What's going on there? Eternal gastropod. Donc, il Motte, société d'histoire. Et qu'est-ce qu'on veut? Ah, c'est des crinoides, je pense. I think those are crinoids. It looks like a whole bed of something or other. I mean, maybe it's the stromatoporoids, maybe it's the bryozoans in cross-section, some sort of tubular creature. There's a big one, I guess. Love looking at these blocks. This is a real geological service here, putting these blocks up here. It's interesting. Interesting shape on that. Yeah, so clearly it's eroding in an interesting way, but you can see the bedding. Oh, interpretations. Interpretations are hard to come by. Again, layers of shelly material, tubular. Whoa, that's intense. Those flies that look like they are getting it on. Come on, can we focus? Can you see that? Are you alive? Oh yeah. Oh, I'm sorry. Oh, fuck. Okay. Sorry. Yeah. Yeah, you need time, you need space. But above all, wait, where'd you go? Oh yeah. But above all, you need appreciation. You need voyeurism. Oh, that's okay. Who are you? Yeah, millions of eggs. How many million you making? How many million? Probably many. That's what I'm guessing. Many million. All right, continuing on. Focus all messed up now. These look to me like possible bryozoans, tubular organisms. There's that interesting shell. Maybe that's a gastropod from the side. Tubular structure. No one's gonna question the reef assumption or the reef hypothesis. I mean, why would we? But it's just so obvious. You look at these rocks. What do we got over here? Not too much that I can see. But I know right here. Oh, this is glorious. Gastropod. Picked out in 3 dimensions. The shelly material looks to be more erosive. This dolostone holding up a little better. But that's like the best one. Thanks, Société d'Histoire. Really appreciate your help presenting this. Right by the door. A little spongy sponge, maybe? Hard to say. God, I really fucked up the focus on this. Bunch of fun little thingums. Spongies? Peut-être. C'est peut-être.